Word problems get us all worried, but after this video, you'll be a pro at solving word problems about LCM. So stay tuned. Hello, everyone, and welcome back to Mathies with Miss C. So far, we've learned what the LCM is and how to calculate it using prime factorization. But today, we're going to take things a step further. We'll learn how to apply LCM to real life word problems. If you missed out on the previous videos about LCM, I'm sharing the link in the description box below. Make sure you check them out before you start this one. Now, solving word problems is where math becomes practical. So let's not waste our time and get started. But before we try to solve the problems, let's first understand when we actually use LCM in real life. This way, when you come across any problem, you'll know right away that you need to find the LCM. So we use LCM in three different situations. The first time is when things happen again and again, like repeated events or timings. This could be anything. It could be the time two people take to do something or how alarms go off again and again after certain hours. The second time is when we have different cycles or schedules and we want to know when they'll match up. This could be a train schedule of two trains and they can ask you after how long they'll leave together at the same time. And the third time we use LCM is when we need to make equal groups or sets bigger. So, whenever you see a problem about repetition, cycles, or matching schedules, that's your clue. It's an LCM problem. So, let's solve our first word problem together. A certain number of students can be arranged in groups of 3, 4, 6, or 8 with no student left behind. We need to find the minimum possible number of students. Now, what does that really mean? It means we're trying to make equal groups, groups of 3, groups of 4, groups of 6, and groups of 8. And in every case, the total number of students must fit perfectly. No remainders, no one left standing out. So for this to work, the total number of students has to be a multiple of 3, a multiple of 4, a multiple of 6, and a multiple of 8. In other words, we're looking for a number that is big enough to be divisible by all of them at the same time. That is exactly what the LCM does. It takes different group sizes and tells us the smallest total that can fit into all of those groups evenly. This is why this problem fits the description of the third point we mentioned before, that we use the LCM when we need to make equal groups or sets bigger. Another clue here is the word minimum, which can easily be used instead of the word least, lowest, or smallest that we have in LCM or SCM. So we're going to find the LCM of the numbers 3, 4, 6, and 8. So begin by writing down 3, 4, 6, and 8 side by side and make the lines we always make while doing prime factorization. So all of these numbers except 3 are even. So we can divide 4, 6, and 8 by 2. 3 can't be divided by 2, so it'll remain the same. So we'll write 3 as it is. 4 divided by 2 gives us 2. 6 divided by 2 gives us 3. And 8 divided by 2 gives us 4. Now we have two more even numbers. Remember, in LCM, even if one of all of the numbers can be divided by that prime number, we have to divide it. So now, since 2 and 4 can still be divided by 2, we're going to divide it by 2 again. So this 3 stays as it is. 2 divided by 2 gives us 1. This 3 stays as it is. And 4 divided by 2 gives us 2. Now we only have one even number left, which is 2. So we are going to divide these by 2 one more time. So we're going to divide it by 2. We write 2 here. This 3 stays as it is. The 1 stays as it is. This 3 stays as it is because all three of these cannot be divided by 2. And this 2 divided by 2 gives us 1. So now we are left with 3, 1, 3, and 1. So basically in LCM, our ultimate goal is to get to the number 1. And 2 out of these 4 numbers have already reached 1. We have to make sure these other 2 numbers get to 1 as well. Now, since both of these 3's are odd, we cannot divide it by 2. So we are going to divide it by the next prime number, which is 3. So we're going to write 3 here and divide them by 3. 3 divided by 3 gives us 1. This 1 stays as it is. This 3 divided by 3 gives us 1 again, and this 1 stays as it is. Now we're left with ones all the way, which means we're done. The final step is to multiply all the prime numbers we wrote on the left. So that is 2 times 2 times 2 times 3. And that gives us 24. The LCM of these four numbers is 24, and this means that the total number of students must be 24. And if you think about it, this actually makes sense. If there were 24 students, we could easily make groups of 3, 4, 6, and 8, since 24 can be divided by all of these numbers. Now let's move on to our next example, which will explain the concept of schedules in LCM. The local bus service has two lines of buses that start together at 8 a.m. Buses on line A leave every 15 minutes, while buses on line B leave every 20 minutes. We need to find out how many times both buses leave together between 8 a.m. and 11:30 a.m. All right, so the clue here is that the buses keep leaving after fixed intervals, which means, like we discussed before, that when things are happening in a schedule and we need to find out when they'll happen together at the same time, we have to find the LCM. So this means we need to find the LCM of 15 and 20 because we want to know after how many minutes both cycles line up again. So we're going to write 15 and 20 side by side. And as always with LCM, we're going to start dividing them by the smallest prime number, which is 2. Since 15 is odd, we can't divide it by 2, but 20 can be divided by 2. So the 15 stays as it is, and 20 divided by 2 gives us 10. Now 10 is still even, so what we're going to do is we are going to divide these by 2 again. The 15 stays as it is again, and 10 divided by 2 gives us 5. Now, both of the numbers we have here are odd, so we can't divide them by 2. We're going to try dividing them by the next prime number, which is 3. So, even though 5 can't be divided by 3, 15 can. So, 15 divided by 3 gives us 5, and this 5 stays as it is. Now, we have two 5s over here. And since 5 can't be divided by 3, we're going to try to divide it by the next prime number, which is 5. So 5 divided by 5 gives us 1, and this 5 divided by 5 gives us 1 as well. So now we have all ones at the bottom, so we stop. The next step is to multiply all the prime numbers on the left side. So the LCM of these two numbers is going to be 2 times 2 times 3 times 5. And that gives us 60. So the LCM of 15 and 20 is 60. This means that after every 60 minutes, or you could say every hour, both buses leave together. So between 8 a.m. and 11:30 a.m., these buses will leave together 4 times. Once at 8 a.m., then again at 9 a.m., then again at 10 a.m., and then final time at 11 a.m. And we're done. But don't think you understood a math concept until you tried solving it yourself. So now I'm going to give you a question which you will try solving on your own. Here it is. 3 painters, Ron, Victor, and Shelley, are painting the rooms of a hotel which are numbered from 15 to 200. Ron has to work in all rooms. Victor has to work in rooms where the number is a multiple of 3. And Shelley has to work in rooms where the number is a multiple of 5. In which rooms will they all work together? Let me give you a small hint too. When we say Ron has to work in all the rooms, we're basically saying that the number we will use for him is the number 1. Think carefully about this one and write your answers in the comments. I'll be checking them out and helping anyone who has trouble understanding. If this video helped you understand LCM word problems, don't forget to hit the like button, share it with your friends, and subscribe to the channel for more math lessons made simple. That's all for today. Don't hate math, keep practicing, and I'll see you in the next class. Bye!